And now let's see the sand fall. Yeah, the sand is falling as expected. And yeah, the sand is not actually falling to a single place or stacking on top of each other. It's actually forming a triangle. The way a sand should actually form. And yeah, I think that looks really good. Yes, hey, 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 welcome back. And as you saw, for the past few days, I was not uploading anything, mainly because I had no idea on what to do. And I was just thinking and thinking. And just like an apple fell over Newton's head, something fell on my head too. And that was sand. And I thought, okay, let's simulate sand falling from top to bottom. And I felt it was a good idea. So, the past few days, I spent researching on how to do that. And I arrived at a good method. And I thought, okay, let's implement that. And I implemented it. And now I thought, okay, let's share how to do that also. And yeah, so the main thing you have to do is actually to render something. And yeah, when you hear rendering, JavaScript should come to mind mainly because that is very handy to render something in browsers. But since I'm using Python, we'll be doing something different. And I'll be using a module called Pygame. Yeah, Pygame is mainly used to render things. What it will do is it will give you a screen on which you can do anything. And yeah, so the first thing you have to do is to actually install Pygame. That is done using pip command. Yeah, you have to install Pygame like this. Pip install and the name of the module. And I have Pygame already installed, so it will come requirements are already satisfied. But when you are installing, it will come different. It will like load some libraries and all. And yeah, so Pygame has few features. Like first, you will have a screen, and in that screen, first you have to declare some background and all. But let's import Pygame, and then we'll talk about that. Yeah, and what you have to do, you have to initialize the Pygame first. So yes, the Pygame is actually initialized. It's showing something. Okay. It's not an unware, it's actually an library. So I don't know why it's anything like that. Let's ignore that for now. Yeah. And yeah, now what you have to do is you have to actually declare the dimensions of the screen. So width and height, let's consider it to be 800 and yeah, let's consider it 800. 800 will look weird because it's actually a square and all the screens are general rectangles. So let's make it 800 and 600. And yeah, so what we'll do, we'll keep a state called running. Yeah, we'll actually set it true. And while running exists, so what you have to do? Yeah, for every event which happens in Pygame, you have to capture that event. So first, let's go over all the events which are happening currently in our screen. So for every event which is happening in our Pygame, so in pygame.event.get, yeah, what we'll do first, we'll declare how to quit the game. If Pygame dot, yeah, we have a Pygame.quit, and yeah, when how will you check if it has quit? So if the event has become equal to Pygame.quit, not just event, yeah, event will actually have a type over here. Yeah, event dot type has become equal to pygame.quit, then you have to actually quit the game. So it's just that running to false. Or else what we'll do? Yeah, let's declare white color over here. Let's declare some colors also. Yeah, it's convention to always write constants in complete uppercase. Yeah. So white is actually 255, 255, 255. And yeah, I think if we okay, false. Yeah, perfect. White is actually 255, 255. So what we'll do? And while the running is actually true, now all the events which have happened in our screen is actually captured. Now first let's render the screen out. So take the we have to first declare the screen for that. So what you have to do, declare a variable screen over, yeah, we are declaring height over here. So screen is actually equal to pygame dot display dot set mode. Yeah, set to the width and the height. Yeah. Now you actually have the screen object. So screen dot fill. Let us fill it with white. Where is white? Yeah, yeah. Let's fill it with white. And now let's run it first and check if anything is happening. Yeah, give it time for it to load. Yeah, we're actually getting a screen. That is what is expected. And when you press into, it will stop. Yeah, you can actually change that icon and all over here if you want. You can change the caption also. Let's keep it time. Let's run it. Yeah, as you saw, the caption got changed. So let's call it sand simulation. Yeah, perfect. Simulation. Yeah. And what you have to do after each rendering is now what will happen is it will just show the white screen. But theoretically, what you have to do, you have to like re-render screen after each frame. So what we'll do, for example, if you want 60 FPS, then you have to set the time delay by 15 seconds, I think, because 1000 divided by 60 is approximately equal to 17. It's 16.66. So let's set our frame rate to 60. And then after while whenever you're running and for any event which is captured, it does not matter. We have to update our screen. So the updation is actually done using the flip keyword. So in other words, you have to take the pygame dot display and then dot flip. Yeah. What will happen now is that whenever running is through, our screen is actually being constantly updated. When according to our frame rate, it will get updated. So pygame dot time dot delay. Yeah, take 1000 and divide it by the number of frames you want to get the actual frame rate. So let's divide it by 60 and let's double divide it so that it is always an integer. Now you will actually have the frame rate of 60. Okay, let's just run it once again to check if we have broken our code anywhere. Yeah, nothing has happened. And if by chance, if you change the values of this, what will happen is that your screen color will also be changed. It's blue, yeah, it's pink, it's magenta, so the color has become magenta. Let's set it back. Yeah. So now imagine what you have to do. First of all, we are actually simulating a sand particle falling. So what we'll have to do, we will actually have to declare our sand particle. So let's declare the particle. Particle is actually what? Like each particle will have a size, right? So what you have to do, you have to set the particle size. So yeah, first let's set the particle size also. Let's call that particle size. And yeah, let it be 2 pixels. So if it is 2 pixels, what that means, like I hope you understand, if the particle is actually 2 pixels wide, then you have to actually set the entire grid width and the grid height to be equal to particle size, like the actual width divided by the particle size and the actual height divided by the particle size to get it in the form of coordinates. Like you want to, let me just run it. So you have to convert it into 2 by 2 blocks, grids everywhere. So and each grid should have a size of 2. Each box should have 2 pixels width and 2 pixel height, so that we can actually simulate the sand falling. So this entire thing has to be divided into 2 pixels, 2 pixels, 2 pixels, 2 pixels, 2 pixels like this, and 2 pixels like this, right and left, to have a grid of size 4 pixels. Like the area of that grid should be 4 pixels. So let's do that. Let's call that grid width, and grid height. Yeah, grid width. Yeah, no spelling mistake. You actually take the width. Okay, why did it go there? Take the actual width and divide it by the particle size, and then take the actual height and divide it by the particle size. Yeah. Now what we'll do is that we have to like keep track of the state of our current board. So we will. declare another array called, I don't know, let's call that grid. Actual grid is actually what it will be. It should actually declare the state of the array, like the state of our entire Pygame screen, and it has to have a size of 4 pixels in area. Yeah, the actual area should be 4 pixels. So what you have to do, first actually set everything. That means grid height, grid width. Yeah. Now what will happen is that your entire grid has been divided into 4 by 4 area, 2 by 2 area. In other words, 2 by 2, two width and two height. In other words, 4 area. Like it has not actually been divided, but we are just considering it to be divided over here. So this will actually divide our entire grid into each block, which has an area of size, like which has a size 4, like which has area 4. Now what you have to do? Yeah, like we have to keep track of one more thing, which is the particles, like where are each particle or where are each sand particle is there. We have to keep track of that coordinate. So particles will call it an empty array because currently there are no sand particles in the entire system. And yeah, but let's what we'll do is that we'll actually create each method for each thing to do. First, even for returning a coordinate, what we'll do is that we'll actually make a function for that also. So yeah, so what we'll do, we'll take the coordinate x and y. We'll just return it in the form of an array. This is actually redundant, but I'm just doing it like this. So now what you have to do for each event, now just think of what you have to do. And yeah, how will we actually drop the sand? We will drop the sand whenever our mouse button is down. So let's have another this one called mouse down. Actually, initially it is false because our mouse will not be down. So what you have to do? Whenever our mouse is down, like ellipse event dot type is actually equal to pygame dot mouse down. Yeah, mouse button down. Whenever our mouse button is down, we have to actually set our particle. Like what we have to do, we have to get the current coordinate of where our mouse is down, and then we have to create a sand particle over there. So let's just get the current coordinate of that point. So mouse underscore x and mouse, yeah, it's mouse, yeah, mouse, and comma mouse underscore y. It is actually equal to the pygame dot pygame actually has an attribute called mouse, and that dot get position. This will actually give you the position, and let's just print it out once. Mouse x and mouse y. Yeah. I always tell whenever you do something, just print it out to check if you're doing properly. Okay, it did not break. Thank God. We're actually getting this should be 0 0 or 1 1. Yeah, this is 0 0, and this should actually be 600 and 800 or 800 and 600. And yeah, it's 8 and 600. Yeah, that's what that is the actual size of the screen. So whenever we have our mouse to be down, what you have to do? You have to add a sand particle over there. So we call it add sand at position. Yes, and that's what is expected. Now let's fill the let's declare an add sand particle, or just it's called add sand. Let's make it more clear. Yeah. You are actually getting the x coordinate and the y coordinate. And so what you have to do, you have to take the current coordinate, and to that current coordinate, you have to add a particle of sand. So what you have to do, create a particle of sand first. Yeah, we'll do one thing. We'll actually create a class called particle, which will actually like particle will actually have the attributes of sand. Like it will have x coordinate and y coordinate and the actual sand color. So and you'll have the x coordinate, and you'll have the y coordinate, and then you'll have the color. So self dot x is actually equal to x, self dot y is actually equal to y, and self dot color is actually equal to color. Yeah. So what we do, I think we can directly remove this because we'll not use that. We are actually directly creating a sand particle, so there's no need of that. So now what we do, just create a particle which has x coordinate, y coordinate, and we will declare our color over here. I think the I have already noted down the color of sand particle is 194 and 178 and 128. This is actual sand color. Where is Yeah? Let's just remove this print statement because it's not actually essential, and we'll add the color. It's actually called sand. Yeah. Now we actually have the particle, and what you have to do, put it inside the particles array. You have declared an array called particles, right? So you have to update our particles dot append. Yeah, put the current particle, and what you have to do, tell that okay, that grid should actually be set to 1 because we are actually putting a sand particle over there. So what we'll do, we'll take grid because we have actually declared our grid also. I told you like the grid will have where is that? Yeah, the grid will be of size, like each grid inside the entire grid will be of size 2, like it will be 2 width 2 height. In other words, it will have an area of 4, and we have to fill, we have to tell okay, that part should be actually filled with a particle. So what we'll do, we'll take the actual x coordinate, x coordinate and take the actual y coordinate, and yeah, again don't forget I have to divide it by the particle size, or else you'll get index out of bounds, and set it to 1. Yeah, and that's how you add a particle of sand. Now we actually have to render the sand particle also, right? So regardless of whatever event has happened, we have to render the sand particle. So what we'll do, we will call one more method. We'll call that draw sand. We have to actually draw our sand particles, and it will not actually take in anything. So we'll call draw sand. So what you have to do, go for each particle, in particles. Yeah. So what you have to do, pygame dot draw. What do you want to draw? You want to actually draw a circle of. We'll draw a circle of sand. So where do you want? Okay. Yeah, and the whore or yeah, it is actually given. Where you have to draw? You have to draw on the, yeah, you have to draw on the screen with the color, with the coordinates and the radius, and yeah, and the width. Width and height are actually set to default. Default set to 0, and yeah, remaining everything else is set to 0. Like they are set to default values, but we have to define where we have to draw, what we want to draw, those things you have to draw. So set. So we'll do on the screen you have to draw. So what you want to draw? You want to draw the particle. Yeah, you don't want to draw the particle. You want to draw the color of the particle, defined as color, right? Yeah, you want to draw the color particle of the given color, and the coordinates. Yeah, see color value, and then the coordinates, surface color value, and then the coordinates, which is actually particle dot x, particle dot x, and particle dot y. Yeah, so to draw on the x and y coordinates. Yeah. So now what you have to do? Let's just run it once. Yeah, I forgot to give the radius. The radius is actually the particle size. Yeah. Yeah. That is what you wanted to see. Let's increase the particle size so that it's a bit bigger. Let's keep it 20 for now. And yeah, let's go. We are actually able to draw particles on the screen. First part of our work you've done. So now what you have to do? You have to tell, okay, the particles, what in general happen when something is kept on top? It will have potential energy and it will gradually convert it, and then it has to reach a ground state, right? In other words, whenever our particle reaches the ground, we want it to stop. So we have to simulate it falling from top to bottom, and that can actually be easily done with the help of our grid. That's the main reason we declared our grid. So what do you have to do? Yeah, after before drawing the sand itself, what we'll do, we'll actually update our entire screen to like what is happening. So we will particles is equal to, yeah. I'm doing like this because we have to actually update our particles array also. And then let's declare our update particles. Yeah, they're actually getting you're getting the particles array, and we will have updated particles. UP DATD. Yeah, you are telling mistake. That's very good. And we'll actually return the updated particles. You have to return the updated particles. Yeah. Now we have to fill our updated particles value. So what we have to do? So again, go for each particle in the particles array. What to do? Get the current x and y coordinate, and yeah, it is actually stored in the x and like particle x and particle y, and you have to convert it to grid x and grid y, and that can easily be done using like by dividing the actual particle position divided by the grid size, not the grid size, divided by the particle size. That will actually give you the grid x and grid y. So yeah, take the particle dot x and divide it by particle size, and take the particle. You can actually declare these also as coordinates into the particle itself, but that does not matter. But I prefer to do it like this: particle dot y and divided by particle size. Yeah. Now we actually have the grid coordinates of x and y, and so what you have to do, while the actual grid y is less than the grid height minus one. Yeah. So what you want to do? You want to continually change the y coordinate until and unless we reach the bottom of the grid. So if you don't add this condition, what will happen is that after the sand particle reaches the bottom of the grid, it will just go out of the screen, and you don't obviously want that. So what you have to do? While the grid y is less than the grid height minus one, and the grid is grid, yeah, and the grid at the position grid x at the position grid y plus 1. So what you have to do? And until the next line or next column is equal to 0. That means that the column is actually free. What you have to do? Like the current coordinate is not out of bounds, and the next column is actually 0. What you have to do? Take the current coordinate of the grid at the position grid x at the position grid y. So what you have to do? Set that to 0, and take this coordinate and set that to 1, actually telling that, yeah, we can actually go to the next coordinate. And what you have to do, take the take the particle, take the y coordinate of the particle, and increment it by particle size. So what you're telling, okay, since the next coordinate can actually be filled, take the current particle and put it to the next put it to the next grid, or and the next grid is actually of size particle size. So you are taking the current particle and moving it one step down, and you are taking the current grid and moving it one step down. So you're not only updating the particle, but you're also updating the grid so that the particle gets properly placed. Now let's just run it to make sure that we are not broken anywhere. Yeah, and again, nothing will happen mainly because even though we are doing this, we are not actually updating our particles. So after everything is done, what you have to do? Take the updated particles. To that, you append the updated particles. Yeah. You don't want to take the actual function. That makes no sense. To that you append the current particle. Yeah. Now it should work. Yeah, that's what is expected. But hey, that should not actually happen. What? Sand particles should not actually stack on top of each other. That makes no sense if you imagine. And as you see, the higher you drop from, the down it's going, and the lower it's drop from, it is just stacking on top. That is some happy accident. I don't know why that's happening, and I have no issues. And yeah, sometimes particle goes out of screen also, but that should not happen. So what should happen is whenever a particle gets tagged, if the left or right is free, our particle actually has to move to that left or to that right. So what we have to do? Yeah, and one more thing, if you want to like mess with gravity, so you can do that also. Just to make this particle yes. So now what will happen is rather than falling down, it will actually fall to the right side. Whoa, shocking, right? But yeah, when you're doing that, you just have to change the value of this one over here. You should actually tell, yeah, grid x should be less than grid width minus one. That then what will happen is that this one, and again you have to change this also. It's not yet done. Again, you will get an error as soon as it moves out of screen. Okay, yeah, it's not getting an error. That's what you want. But what is happening is that as soon as we have two blocks on top of each other, it's not actually falling, and you don't want that also actually, like absolutely. So we'll take care of that also. Now let's change it back to grid X. Yeah. Yeah. Now let us just run it to make sure that it's actually falling down only. Yeah. Again, it's stacking on top of each other, and let's take care of that. It should not happen like that. So what you have to do? Yeah. And so what you have to do for particle in particle? Yeah, it should not actually be a while loop. It should actually be an if loop over here. I don't know why I did why. Yeah, now it's actually working properly. That was the reason. It should never be while loops. And if I do shift tab, yeah, now it will not go out of screen, I think. Yeah, that's what we actually wanted. Since I had if loops, it was actually behaving a bit weirdly, and I was thinking, okay, that should not happen. Since I was having while loop, it was behaving a bit weirdly. So yeah, now let's just like implement it because we have to handle the other cases also. Else if yeah, else if it actually else if. So what you have to do again, you have to do the same check, telling that okay, our coordinates should actually not be out of bounds, and the this position if it is actually equal to one. So what does that mean? Yeah, that means that you actually have a particle over here. So what you can do, you can actually now you can just check if like the left is free or the right is free, and yeah, you can actually add randomness to that also. Now, for currently, what we'll do is that whenever we have a particle at the down, we'll first we'll check for left and then we check for right. But if you want, you can have one more random, like you can declare a random dot random and then mod it by 2 and you'll get some value. And if that value is even, then you can tell, okay, go left, or else you can tell go right, but you will not actually take care of that because that's not actually that much essential. So what you have to do, first you'll always check for the left value. So first check if the grid x is actually greater than 0. That means that you're not like left side of the screen because you obviously don't want that. And grid at the position grid x minus 1 because you're actually checking for the left coordinate of the next column. So you have to check for the left coordinate of the next column. You have to take grid y plus 1, and if it is equal to 0, that means that the down left is actually free. So as soon as you see down left to be free, do this. Yeah, but now what you have to do, you have to actually change the particle x and particle y also. So what you have to do, take the particle x, change the particle x should actually go to the left part and particle y should actually go to the bottom part. So particle dot x and plus is equal to particle size and particle y should actually go to the down part. So no, it should actually go to the left first or to decrement it, and y should go down. So you have to increment it. Let's just run it once. Did I break anything? Okay, nothing broken. And let's just have it outside the loop. Yeah. See what is happening is that our particle is coming and it's just going to the left as you saw. Let's just increase the frame rate. Let's make it 20 frames per second. Let's keep it a bit slow now. Let's not have it really fast. Yeah, it's going to the left. As you see, as soon as the particle falls, it goes to the left itself, and that's what you actually wanted to see. Now we will have to actually do the same thing for the right part also. So what you have to do? Yeah, do the same thing, and don't copy and paste. Else if or else the grid y is actually yeah, the thing which we did over here. You have to take the grid y and then make check if it is actually equal to grid height. No, you should take grid width because grid height is actually from top to bottom, and actually have to go to the right side and the same condition. So you are checking if the current y position is actually in range, and the next position, like the next column is actually one. That means that again you have to do the same part, like take the current grid at the position grid width, not grid width, grid x at the position grid y. Yeah, actually set it to 0 and do the same thing. Yeah, but now we have to modify this. And the modification is actually pretty simple. You just have to tell the particle to go to the right. So just take the particle x and increment it by one. And after doing this modification, what we'll do, we'll just take the particles. Yeah, just update it. And yeah, I think that should be it. And let's just turn it on. Yeah, particle fell down. It is not actually stopping. Why is that? What you have to do? Let's just bring it out. Let's comment this out. And now let's check. Yeah, it's actually stopping, but it's going to the left. Okay, that should actually not happen. It should actually stack on top of each other. That means that we have messed somewhere up. Updated particles. We are actually taking the grid x and the grid y. And then what we are doing, taking the current grid and setting it to 0. And then we're actually taking the current particle size. And then we are actually setting the grid y at the position 1 to be equal to 1. That's actually as expected. And then we are checking for the y coordinate, and y coordinate is actually less than grid y minus 1. So yeah, that is also as expected. And then we are returning the updated particle. Since we are updating both sides, we have to keep it like this only. Yeah, I think I found out. I think it's mainly because we have to actually, yeah, we actually updated the x and y variable over here, but we did not actually update the x and y variable over here. That was the issue why it was not stacking on top of each other. So what you have to do, since the x coordinate is actually going negative, you have to actually modify the x coordinate over here also and increment x coordinate over here because we are actually incrementing the particle x. Now let's run it. Yeah, Let's just tell it to be outside. Yeah, let's decrement the particle size. See the particle size 2 for now, and let's just check it out. Okay. Now again, it should actually stack on top of each other. That means I have messed up somewhere again. Let's run it now. And again, it's not actually stacking on top of each other. Why is that? So we are actually incrementing y. We are decrementing x. Grid x plus 1 and grid y plus 1 are incrementing. When yeah, it should be grid x because they are actually checking for the x coordinate. I think that was the issue. Let's just check it out once. Let's increment the particle size. Let's set it back to 20. Yeah, particle into the left, particle into the left, particle into the right because left was filled. Yeah, I think you have to add another condition. Else what you have to do? You have to take the current. Yeah, actually should not. There should be no necessity to add another condition. Let's just see properly. Why there might be some small issue which we are doing. So what we are doing, going through each particle. For each particle, we are actually taking the grid y. We are actually calculating grid x and grid y, particle dot x and particle dot y. And then you're first actually checking for that if the current grid is actually less than the grid height and the next coordinate is actually 0, that means that you can actually go down. So we're taking the grid at the position grid x and grid y are setting it to 0, and we're taking the particle and telling it, yeah, you can actually go to the next column, and then you're actually taking the y index and incrementing it by 1, that's expected. Or is while the grid y is actually less than grid height minus 1, yeah, that's expected, and the next column is actually occupied, so you're telling grid y plus 1 is actually 1. What do you have to do? If the grid x is actually greater than 0, that means we can actually go to our left, and the grid at representing grid x. Yeah, okay. And the grid at the position grid x minus 1, that means we can actually go to the left, and the y plus 1 is actually equal to 0. Yeah, oh, I have to add plus 1 over here, mainly because we are actually going to the right. There's no need of else over here. Now let's run it. Let's do like this. Going to the left. Yeah, now it's stacking on top of each other. Actually, directly going to the left and swapping. That means we are actually messed up our y coordinate, I think. So if grid x is actually less than grid width minus 1, that means you can actually go to the right, and x plus 1 at the position y plus 1, if it is actually equal to 1, uh, so that means that we can actually go to our right. Okay, again, this should not be equal to 1, this should actually be equal to 0. That means that we can actually move over there. Why I wrote 1, I don't know. Yeah, fell down. Perfect. Perfect. Yeah, now it's stacking. It was because of that issue. My God. Now, as you see, It is actually working as expected. Yeah, be very careful. And as you see, oh, it's not looking that, it's looking good only. And that's how actually sand must work. And yeah, like this is the main crux of the application. Just don't do mistakes like me. And as you see, the actual particle is actually flowing left. As soon as it has space on the left, and as soon as the space on the left gets occupied, it will actually flow to the right. Yeah, that's what is expected. Yeah. So what we'll do, I think it's better if we implement that random part also. So only, yeah, but yeah, that actually becomes complicated. So let's not do that for now. At the end, let's see if we have time, we will do that. And what we'll do is that rather than drawing one particle of sand, we will draw a big bunch of sand. That will be cooler, I think. So size, we'll actually draw 10 pixel by 10 pixel completely with sand. So and then what we'll do for, yeah, we want to draw 10 pixel by 10 pixel of sand. So we'll iterate through our sands loop, not draw sand loop. Oh, you should not actually mess with this over here because we have to actually add the sand. Yeah. So yeah, for this one in range X, and for the other sand in range Y, in both the range sand, I mean, what you have to do, calculate all the coordinates possible. So dx and dy will actually be the coordinates. So it will actually be equal to the current coordinate, which is x called and y called. To that, we have to actually add the size. But rather than directly adding the size is also good, but that won't actually ensure your randomness. You will do both of this. Yeah, but we have to actually verify if the current dx is actually within the range. So we have to like verify it. Or yeah, I don't think there is any necessity to verify. Directly throw everything inside and you'll change x coordinate by dx and the y coordinate by dy. And again, we have to change this over here. So it has to be dx and it has to be dy. And let's decrement the particle size for now. And let's run it again. Yeah, look at that. We're actually having a long line of sand. That's mainly because we're not actually varying our dx and dy. We are just incrementing the size. So yeah, this also looks fine, but that does not look that good. Just pouring sand from top of each other. So yeah, let's just mess around with that. So what we'll do? We'll do x minus and y plus. So now what will happen? Just think about it. I think it should fall in diagonal way. So let's just save it once. It's not actually falling in diagonal. That's shocking. I thought it would fall in diagonal. We'll do one thing. We'll make both are minus. Now it should, at least it should fall in a weird way. It is still falling right. Why is that? Yeah, let's not think about that too much for now. Yeah. So now what we'll do? Dx and dy, x called y called, add dx dx. Let's just add another 100 over here just to see what will happen. Let's just mess around with the values. We are not set for anything. Now it should actually be, yeah, it's actually falling in a different direction. That was the reason. It is that now actually the sand is not falling from the place I clicked. Yeah, it's actually falling from a bit, like it's falling from top. Mm, yeah, I think yeah, that's it. We'll actually make it so that the sand is actually falling in a circular pattern. So what we'll do? Uh, we'll take our we'll take the current size and we'll just take generate a random number from our current size. So let's import random for that. Importing the random is the way to do. And yeah, we'll do plus random dot random from minus size to size. Again, you want to do the same over here also. Dot random from minus size to size. Now let's run it once. Yeah. So rather than being clumped up, it's actually like we are getting in the form of handful of sand. What do you call? And as you see, the sand is actually behaving like sand. It's not like behaving weirdly. But why that happen? If you do just plus size over here, what will happen? Because I thought that would actually give you some randomness. Yeah, now we're actually having it. Okay, yeah, I think I understood. Now we are the x coordinate is actually remaining constant. The y coordinate is actually remaining constant, but the x coordinate is constantly changing. That's why we're having it like this. So that means that if you do like just do plus size, you know what will happen? Yeah, the sand is actually getting stacked on top of each other and then it's falling. That was the reason. And it did not fall in from diagonal. Yeah. And then now we can add one more thing. So what we'll do is that as long as our mouse is actually held down, we'll keep on constantly adding sand. And as soon as our mouse gets lifted up, we'll stop adding sand. I think that is actually a really good thing to do. So we'll do that also. So what we'll do whenever our mouse is down, so what we have to do, we have actually declared mouse down to be false. So mouse down will actually set it true, and then we'll add sand. And what we have to do, else the event or type, the type of the event is actually equal to pygame. There is pygame. Oh, it's not here. There is pygame dot button mouse button down. No, no, it's not mouse button down. We actually have the mouse button down to be declared. So what we'll do, we'll just tell whenever our mouse is moving, you have to check. So mouse motion. Yeah, whenever our mouse is in motion, and whenever our mouse is actually down, mouse down is actually true. We'll just add sand. We'll yeah, where you will add sand? We'll actually add sand in the current x and y coordinate. You don't want to add sand randomly, but whenever our mouse actually becomes like whenever we release our mouse, so what we have to do, we have to stop adding the sand. So event dot type is actually equal to pygame dot mouse up should be another property area. Yeah, when the mouse button is up, set mouse button to false. So we have called it as mouse down to false. I said mouse down to false. And now let's just check if I have broken something. Yeah, and as you see, as long as my mouse is held down, the stand is actually for getting released, and as soon as I release it, it's actually stopping, and yeah, it's slowly falling, and as soon as it reaches the ground, it's actually rearranging itself in the way a stand would rearrange itself. Let's increase the frame rate. Let's make it 60. Yeah. Now you can actually see that the falling down is smoother, but as long as we add more and more things, the load on my system will increase and it will start to slow down. And since my system is not that powerful, uh, it will start to lag. And if I increase the frame rate, I don't know, let's make it 120 FPS. And now what will happen? Yeah, as you see, the falling is actually really smooth. But as soon as I add more and more, it will start to lag, and you would never want to see lag because yeah, that's pretty sad to see lag. And yeah, that looks good, but we can make it more good. How? Rather than having a constant color sand, we'll make it what do you tell? Good color. So how we'll do that? Again, we have to update our. We will not mess with our draw sand. We'll actually update our add sand itself. So we're actually adding the sand color over here. So what we'll do? We'll have x comma y comma z. The it's actually r comma g comma b. It's actually equal to random dot random 0 to 255 because that's the range of colors of RGB. So we'll do the same for all the three random. Okay, random, and then we'll release the random over here. And we'll do rather than directly putting sand over here, we'll add the color, which is r comma g comma b. Now what will happen? Yeah, wow! Look at that, different colors and I think this looks much more better than having a sand of constant color. And as you see, the sand is actually holding its color also; it's not changing. Like as soon as new particle of sand falls on top of it, the previous colors are not actually changing, and that's what you want to see. And yeah, that's the main reason why I created a particle class over here. And I'll just show you what will happen if I don't create a particle class. Yeah, but what we'll do, we do that because again we have to like refactor our code too much. Yeah, I think I'll not do that because we have to refactor our code too much. But what will happen is that as soon as we add a new sand, the entire sand color will change, not just the added sand, but the entire sand color will change. That's the main reason why I added a particle object and like I created a particle class and added a particle object. And yeah, now that looks so good. Let's look at it again. Yeah, that looks exceptionally good. Look at that. And as soon as it reaches the bottom, it's actually holding itself in the form of a stack, not stack, in the form of a mountain. And yeah, sometimes this will happen. Just ignore that. Wow, that looks so good. Let's go. If you have followed till now, you can give a pat on your back. And I think the only thing left to implement is the sand falling randomly. If both, see, again, I'll tell where was that. Yeah, now we'll do that also. Why not? So, yeah, we'll make it so that sand will fall randomly only if the given x and y coordinate are actually zero. Like the left and the right should be zero. And what should happen? The left like the left bottom and right bottom should actually be equal to zero. Yeah, this should be in bounds and this should be zero. So we'll do that. So yeah, this this and this is actually equal to zero. So what we'll do? Random dot random. Don't know from zero to will take 1 to 1000, and we'll actually mod it by two, and we'll set it in val, and we'll actually set it to is it equal to zero? So if it is actually equal to zero, then what you have to do? Yeah, we'll just tell yeah if our value is actually zero, we'll actually go left, and yeah, we'll just make it if this value is actually equal to zero. That means we'll actually go left, or else what we'll do? We'll actually go right. Yeah, thankfully we have written those functions, so we don't have to type it out again. And yeah, let's just make it like this. Then we'll have to add else if. And yeah, now what we'll do is that rather than having a big stream of particles, we'll just have one particle and check out. Where was that? Draw particle. Yeah, we'll just comment this part out for now, and we'll do a shift tab over here, and one more, and then we'll just remove this part, and then we will remove this part. Yeah, now it should actually behave in the same way. And let's just increase our particle size to 20 back. Let's increase it back to 20. Yeah, our sand particle fell down. Yeah, it's not always falling to the yeah, see, it's not actually always falling to the right itself, because before what we did was that whenever a sand particle fell, we always force it to fall to the left, but now it's not actually falling to the left. It might fall to the left or it might fall to the right. I think this looks much more better. This is more sand-like property, because as soon as we have a free space, it's not like sand will move always to the left itself. So yeah, we'll change it back to 0. Then we'll change it. Where was that? It was in add sand. Yeah, in the shift. No, we have to do tab. We have to do this one, and we have to do shift tab because it got indented. We have to do tab over here, and we have to do plus random dot random from minus size to size to have a square blob, and do the same thing over here also. And we have to indent it once more. Yeah, be sure to take care of indentation in Python, because if you don't indent, you'll be left wondering where you went wrong. Yeah, now again it is falling, 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 and now it will be more sand-like. Yeah, this looks much more better. I think we'll reduce the frame rate, because my PC will, I don't know, catch on fire now, and that looks really good. I will just increase the particle size to 6 and see what will happen. Yeah, just mess around with the values. Oh, look at that. Yeah, sometimes it shows some weird behavior. Just ignore that. And I think it's looking really good. Color sand. But when you have big particles, it does not look that like. Yeah, let's keep it one. I think one will actually simulate really slow falling. Yeah, this is the issue with having frame only one size particle. It will actually fall really slow, and we'll have it to be. Yeah, I felt two was the proper size. And yeah, if you want, you can change the value of size over here also. We'll do 20. This will mean that bigger blob of sand will be formed on wherever you click. Yeah, as you see, the sand blob is bigger, but as soon as you add more sand particles, what will happen is that if you have a very powerful computer, then you have no issues. But when it is not as powerful, if it is like my computer, then you obviously have frame rate issues, and it will start to exhibit weird behavior like this. But yeah, I think it's looking really good. And yeah, the only thing, what other we can mess with is, yeah, rather than drawing a circle, we'll draw what are the other options available. We'll draw a rectangle. Yeah, that looks weird. Rectangle piece of sand. Okay, I think rectangle has some. Yeah, it will not have particle size over here. I think. Okay, it should have a surface color, and you have to have a rect object over here. And I don't know what rect object should contain. That's pretty sad, because I mainly did circle, right? So width and border radius. Yeah, other values are set to 0. But rect is equal to, yeah, I don't know what that should be. That's pretty sad, I think. I will just Google it. What does that happen? Yes, I think my network is slow. Oh, my network went actually. That is the biggest issue. Both connected. Yeah. If you don't know anything, just I think it's better to directly look at the documentation because you'll get to know what you have to add. Yeah, you have to wait. Oh, okay. It has to try again for storing rectangular folders. So you have to have yeah. You can't directly have one like radius and with this one. You have to actually give the left, top, right, bottom. Yeah, you have to have a rect object like this. I think that is just a big pain to do. Should I do it or not? Just try it out. Yeah. Let's look at we'll call it x comma y comma z the width comma height will actually be equal to 0 comma 1 comma 2 comma 3. What do you have to do? The actual it is actually again rect over here. Mm, I will just increase it. And yeah, it has a surface, it has a color, and then you have to provide the rect values over here. We will remove this part. Yeah, again, for this, what you have to do, you have to actually modify a particle also, and you'll add W and H also. Particle dot W and particle dot H. Will it run? I think this will break the code. Yeah, yeah, we have to modify the particle over here also. We'll keep the width and height same. So particle dot W and particle dot H. And let's see how bad our code is broken. Oh yeah. Uh, for temporary, we'll keep it one and one and see what will happen. I just experiment with what is going to happen because even I don't know because I have not tried out with rectangle. But I feel that yeah, as you see, particle. Yeah, what we'll do is that we'll actually increase the particle size. I will keep it 10 for now and see what will happen. Oh, what do you have to do? I think it is because the width and height is actually one. That's why the particles are becoming really, really small. Yeah. Oh my God, that looks weird. That's how the actual grain of sand is actually. We'll just keep it 5 and 5. No, 5 pixels is too much. I think we'll keep it 3 pixels of 3 pixels. And now what will happen? Yeah, that is looking really weird. Yeah, that does not look that good. So we'll actually change it back to a circle only. Yeah, you circle it. And you turn it once. Yeah, that's what you actually wanted to see. Circular sand falling, not the square or rectangular sand. And I think that looks really good. I think this might be resume worthy also. I don't know properly. But the simulation is actually happening really, really well. That made me really happy when I first implemented it. Is there anything else? Yeah, this and all would be good, but again, surface color you have to provide it with the correct value. And should I do it? Ah, nah, let's not do it, man. And by now, I'm pretty sure that no one will be watching also. Yeah, we will have circular sand itself. Let's not go with square, elliptical, rectangle, any sand. Yeah, and I think that's all for it. Just look at sand falling and be happy. That is actually, this is actually like really good. Not going to lie with you. And yeah, as sand falls, we'll end the video. And yeah, thank you for watching. See you next time. And goodbye. Grind more sand now.